Welcome back, Math 30-2. So today we are going to do, let me go back up here, modeling data using exponential functions. So we are going to do just kind of regressions, really. We're just going to do similar regressions that we've done before. I'm going to show you both ways on the TI calculator and the Desmos. Some of you have asked about the TI calculator. How do I know it's a good regression? Apart from looking at the graph to see if it fits properly, remember that you can also go into the catalog here. So go second catalog. And if your calculator is being reset, this is probably changed. And you want to go down to the Ds. You want to go to diagnostics. So you can just scroll down, but you can also go alpha D as well, I believe. Here's D. Well, let me go down there. What maybe we did? Alpha D. Yeah, there we go. Alpha D. It goes down to the Ds for you. We want to go to diagnostics. So I'm going to turn that on. So diagnostics on and off. I want to make sure that's on. Hit enter. Hit enter again. Oh, you actually want to quit out of this first. When you do it, you want to do it on the regular screen here. So second catalog, alpha D. Alpha D, come on. Stupid thing. Oh, there it is. Okay, we found it. Just took a little bit of time to refresh. Go down to diagnostics on. Hit enter again. It should say done. So that turns on this R square value, which helps us determine, is it a good regression? Now, we're in the exponential, so all we're going to do is just exponential regressions anyway. So what we're going to do from these next sets of graphs here is just determine, are these exponential, these three things here, are they exponential? This fourth one here, we're going to just use, it says here, use exponential regression to do it. We're going to answer some questions. These first three, I want to determine, are they exponential growth or decay? Are they neither? Is it good to use those? All right. So if it is exponential, I want to know if it's decay or growth as well. Is it increasing or decreasing? I could just circle the answer here. All right. So there's a few ways to figure this out. You can find out a common ratio, but we can just look at the graph data, because sometimes the data here is not going to be the best to determine that. So I'm going to put this data into my calculator. So here's my calculator. I'm going to go this side over here. Okay. And all that. So there we go. So remember on your calculator, do this on the TI calculator. I'm going to go stat. I'm going to go edit. And in the first column, I'm going to put all the X's. So on the top there, so it's 0, 1, 2, 3, 4, and 5. In the second column, I'm going to hit the other one. So I don't have to put all the 0.000s. I just have to put 2. Because if I put those in there, they're just going to get rid of them for me anyway. 12.5. 31.125. 31.25, sorry. 78.125. And 195.32. Oh. Yeah, there you go. 125. Okay. Got all the data in there. I think it's all correct. Everything lines up nicely. So I'm going to go zoom. Well, first I'm going to go y is equal to, get rid of the stuff that's in here. Go up to the plot first. So I'm going to turn on the plot 1. Okay, once the plot 1 is turned on, now I can go zoom stat. So stat, I believe, is number 9, I think it is. Yeah, there it is, zoom stat. So there's my data. Looks like I messed one of my data points up. This 0, 1, 2, 3 data point. This is too low. So I'm going to just double check that. Oh yeah, I messed that up. It should be 31.25. 31.25. Sweet. Okay, so now I have this data in there. Go graph there. I'll put the data points. Now this definitely looks like an exponential growth to it. All right. So what I'm going to do is I'm going to go stat calc and just double check the R square value and see what it's like. So I'm going to go down here to EXP regression. Okay, so EXP regression. Hit enter on that. I can store this. Remember, you can store this in here. So you can go to vars, yvars function there. So you just go over to yvars, hit function number 1, and then pick an equation to put it into. Now, if you have one of the neurons, you can also go alpha trace, and it lists all the y values out for you. Go down to calculate, You notice my r squared is 1. You want your r squared to be 1, or as close as 1 as possible, like 0.999 or so. It's like 0.8 or 0.6 is not a very good regression. Okay? You notice that it tells us two things as well. Our A and our B. Our A is my y-intercept. Remember, that's one of the characteristics we can read from this. And the B is your ratio, what you're times in by each time to get to the next number. And it's bigger than 1. So that means this is a growth function. We can see from the graph too, it was going upwards. And the regression here is going to be y is equal to, we got 2 times 2.5 to the power of x. And that's what that's saying. There's the AB to the power of x. And the A and the B here. Cool. So that one worked out. So I'm going to do for this one here, I'm going to type in the data for this. So I'm going to go stat. I'm going to go back to edit. Now to clear these out really quickly, you can go up to L1 here and hit clear enter. It just clears out that whole row really quickly. Clear enter. You can also go into second mem where it says clear all this, number 4 there. So second plus number 4, and then hit enter. It should say done, and that should clear the list out for you. Let's go back to stat edit. I'm going to punch in these numbers 0, 1, 2, 3, 4, 5. Okay, so those are nice numbers. And 0, 2.1, 4.2, 6.3, 8.4, 10.5. Okay, so that's, I'm not liking this. It looks pretty like you're adding numbers each time, like 2.1, 2.1, 2.1. It looks like you're adding 2.1 each time. And remember, exponential is you're multiplying by something each time, not adding each time, but you're multiplying by each time. So I don't think this is going to be very good. So I'm going to probably say it's neither, but I'm going to go zoom. I'm going to go stat. So it's a pretty straight line. This other line here is from the previous regression. That doesn't look very exponential. It's got to have that curve too. It's going up or kind of coming downwards as well. It's not very good in terms of that, but I can also go stat, calc. Let's go down to exponential. That's 0 there. I wrapped it around the other side, so when you hit the up arrow at the top, it just goes to the very bottom. So exp. I'm going to store this equation. So alpha trace, I'm going to put number 1 here. Nope. I'm going to go to, what did I do wrong here? Oh, it just doesn't work. That might be it. If it doesn't work like this, it gives you an error domain. It's probably neither. If it's a really nice linear one, so if I go back to my stat here, quit, sorry. Go stat, go over to calc and do the linear one, AX, this one here, the number 4, lin reg AX plus B. I'll probably get a really good equation out of this. Yeah, there it is. Very nice equation, actually. Perfect for a linear equation. So that's neither. And I'm just going to get rid of that part. You don't need that part. Okay, so let's double check this last one here. Is it a, it looks like if it's going to be an exponential, it's going to be decay. The numbers are getting smaller. Let's double check. Stat, edit. Oh, I got stuck in here. I'm just going to go clear those out first. So second plus number 4 clears that out. So let's go back to stat, edit. 0, 1, 2, 3, 4, 5. Awesome. And then 7,047, 23,049, 783, 261, 87, and 29. Okay. Zoom stat, so zoom number 9, or just go down there. Zoom number stat. Looks pretty good, right? I zoom out a lot, so this looks pretty ugly, this y-axis here, but it does look like it's decay to me. So if it is going to be, it's going to be decay. That's what it looks like it's going to be. But let's just double check. So I'm going to go to stat, over to calc. I'm going to do the exponential regression, so number 0 here. Enter, enter, enter. Now, I don't need to see the equation to determine what it is. I don't have to. I'm just going to go calculate. The r squared is perfectly 1. It gives us this b value of 0.3 repeating. So I'm going to write this out. It says my a value is 7,047, which makes sense. It's my y-intercept. Right, so that's my a value. My b value is 1.3 repeating. What's 1.3 repeating? Is that 1/3? Right? I'm gonna double check that. It looks like a fraction, 1/3. Yeah, 1/3. Okay, to the power of x. So it looks like I'm timesing it by 1/3 as I go down. You can just double check that. By going 4,047 times 1/3. Yeah, that's my number, and I can times it by 1/3 again. That's the next one. There's my next one. There's my next one. Yeah, so that's perfect. Cool. Now, these ones fit perfectly. Like this is like perfect exponential growth and decay function. The middle one's not. If it doesn't fit perfectly, a regression is going to work, but it's going to try to fit the data as best as possible.